Alright, so for today I thought let's try to build a new data structure in my ds.h implementation. Since a lot of people asked about ds.h, I can just add this as a, here's the project if you are interested in it. And we'll also check out how I usually add new stuff to it. And yeah, I thought about the hash table because that's like something really cool and sometimes it's useful. I had some kind of implementation of a hash table, but I'm not really happy with it. So I want to try and make a new one because I think it's gonna be kind of better and more, useful if I also do it here. So yeah, well, first things first, I guess it's what's a hash table and what do we use it for? Um, well, uh, a simple array, if we just imagine that this works in C, is having just items one after the other. That's just a plain array. But in a hash table or hash map, we want to build some kind of, we want to associate a key with a value, right? So maybe our keys are numbers and our values are also numbers. So that's one way. But more often than not, in hash tables we'll have like strings. So name is gonna be, I don't know, John, and then age is gonna be like a number, right? So something like that. And yeah, that's what we are trying to build. So these kind of pairs, right? And you're gonna say, okay, but I see an easy solution, and that's to just use an array and then have tuples. It's some kind of tuples, and that's gonna work. But the issue with this is that now when we search for one of the keys, it's gonna be in of n time, right? And hash tables are supposed to be of one or like constant time because we are able to index with that name directly. So we want to make this optimization because using an array sometimes it's fine. Like I pretty much every time I needed a hash table in my last few projects I used an array, and I did it like this because I knew I had like 5 items in the list, so why bother with building a hash table? But I think it's still useful sometimes. Like imagine you have JSON, like that's this is a really good I guess it's also a good explanation. You can imagine hash maps as JSON, so that's for the front-end developers, I guess. So let's yeah, basically let's try to build this data structure. So how you noticed here, we'll need some kind of keys and the pairs structure, and we'll still keep the same structure like here, like having a list of tuples, but we'll have like different indices in these pairs. So this won't necessarily be the first item and this is the second one. We'll have a special function that takes in a key and gives us the index where we need to save this pair. So that's like when we are gonna search for a certain item, we run the same function again and we get the index where we have to search. So that's why it's gonna be O1. So let's type the struct, and this is gonna be, I'll still call it with ds in the front, like prefix. So that it's easier, I guess, to, let's say, identify this, or put it into ds.h pretty much. So key HashMap kv, right? I think that's a decent name. But yeah, I mean, this one is gonna be for the example, so we can just say example kv. And then here is gonna be type def struct HashMap. Okay, and let's just check out, ds.h just for some inspiration. Here I am also using this allocator, right, from ds, and I guess I'll add that myself. I think it's not that important for the beginning, so yeah. But let's do here char key, and it can even be void pointer value, right? I wouldn't really use a dynamic array in there. I'd rather use like a separate array altogether, so maybe something like this. Because the issue with the dynamic array is I implemented it more like you just append to it, so it's not really used for indexing. So I should make it like this probably. Okay, that's first thing. And it's gonna be pretty much the same thing. Like we want, and where do we want the item size? Well, here we set this void pointer, so it's like generic, right? So that's the idea. Like sure, we could say it's an array of kv, and then have here like a void pointer for the key. Like, should we try that? Void pointer for the key and void pointer for the value. And this could be that type. And we get rid of item size. I mean, why wouldn't we try it? So, yeah, because maybe it's gonna be more interesting. All right. So now when we initialize, we don't even need the item size anymore, because we know that our items are gonna be this kind, right? And if I search for my old kind of hash table, you'll see that I also had here some kind of hashing function, and a compare function. Yeah, I mean, here I guess I had two lists, one for the keys and one for the values, but I think I want this one more. So yeah, we're still gonna need a hashing function, and the hashing function is just what I said. It takes in the key and it gives us a number which is gonna be between 0 and capacity. We don't even need count, I guess. I don't know why it was, but yeah. So we just need the capacity. So yeah, this index will be between 0 and capacity. And then maybe if you already thought about it, is that hash could sometimes return the same index twice. So I don't know, this could happen for certain cases when we get a collision between two keys, so we get the same hash, and then we just need to be able to compare two keys because they have the same hash. So how do we compare them? Well, for strings it's gonna be string compare, for numbers it's gonna be just minus. I guess that works, right? We just subtract one of the other, and if it's 0, they're equal and so on. So that's how I see the HashMap data structure. So let's have an init function. I would just copy from here, from my ds.h. So ds hashmap init. Let's call it map. And yeah, I don't think we're gonna need key size and value size. I don't know why I needed that, but we'll need capacity, and we need to pass in this function. So this kind of becomes an OP, right? Because it has methods on it. Yeah. Let me just include ds.h. So yeah, we have the hashmap init, right? And let's say that next up we want hashmap. I guess let's do insert, get, and delete. So ds hashmap insert, right? And we do here hash map kv. I mean, let's ask for a pointer to this one. All right, then we do a get, which is gonna write to this kv, and let's also do delete. Well, my logic for this one is you pass in a data structure, right, with the key, and value can be whatever, and this function is gonna set this field of the hash map, so you get back the value. And I think delete should do the same thing, but also delete the key. So should we do const void here, like just the key, or should we also do get? I think also doing get might be useful, like for logging purposes probably. But I also feel like probably just delete. might be better for, you know, performance. So yeah, when you insert, you kind of want to have the key value pair. When you get, you want to override this one, and when you delete, you just want the key. I think that's fair. And obviously we'll need the hash table free. So let's also do HashMap free. Even though I don't usually, you know, do free at the end of my programs, sometimes I do, so let's just have it. Okay, so let's write our main. And in here, I would probably do something like this. HashMap. Sometimes I like to start with is equal to 0 just to know that it was 0, but HashMap init. And let's just say we do map. We do capacity, so let's say 100. And we need a hashing function. My hash and my compare or something. But we need to define these. So unsigned int my hash is gonna take in a key, and int compare a k1 and probably const void pointer k2. Right. Now it's my compare. Okay, so example, like the example starts from here. Yeah, but we need to do the implementations. But for now, let's just imagine that we have it, and we'll do it after we finish this. I don't think so. I'm just thinking, will this return like a status code? I guess yeah, because we are gonna allocate items. So probably we'll have like int result is equal to, or even easier is if is not 0, return defer -1. Right. And here you can say ds hash map free map. We can even say ds log error when we try to initialize the hash map. Okay. So yeah, that's the first step. Now let's try to have an example for insert. So let's do like a small block here. HashMap kv. And I guess this one should work. Like if I do key and say void pointer key like this, so we make it a string, right? But let's do like name. Let's see if this works, or do I need to do something special? It should work, my guess, because these are gonna be allocated somewhere, like yeah, on the stack, and we take pointer to them. And actually these are just pointers, so they're not necessarily copied. Yeah, they're just references, which might make this annoying, but I think that with enough abstraction here, should it, yeah, probably it's fine. I don't know. So let's say ds HashMap insert map and kv. I don't know how this one got there, but if this thing is not 0, so insert didn't work, could not insert into HashMap. Okay, and let's just copy paste this one, and my thing would be, okay, let's have int age is equal to 3, and let's have here age. Right, like let's try to also use an integer for the value. I mean, you can even use structures if you implement the hashing function, right? So now is the interesting part. So yeah, I guess getting an item is interesting. So let's have this stuff. So how I would expect get to work is you set the value to null, you just set the key, and when you do HashMap get, you actually get, or I guess you overwrite this kv. So now we can just ds log info the name is, I guess, value for percentage s is percentage, well, yeah, the name is percentages because I know it's gonna be a string. So char pointer kv dot value. Yeah, and I don't think we need. So yeah, something like this. And probably delete is gonna require just age. I don't even think we need to could not get. So delete is gonna do just delete. I'm not checking it yet, but yeah, I don't think we need to also cast to void pointer. I think that's inferred. So let's just remove that. Okay, it makes it a bit more clear. So yeah, how's the hashing going to work? Well, I'm probably going to try something like we have an unsigned int hash is equal to 0 or something, and then we do a for loop. For loop over the characters in the key because we know it's gonna be a char. Right, so I guess char pointer, I cannot do key, I can just um do something like this maybe. Right, and then we can just for int I is equal to 0, I is less than strlen name I plus plus, and then hash is equal to, usually I do like 31 or 17, some prime number. We multiply it with hash, and then we should add like the int value of name I. Let's see if that worked. Somehow it worked. Right, and then we can just return hash. So yeah, my idea is we take each character from the key and we convert it to integers, right? And for the hashing we can do just like any operation, so that's why I'm usually doing something like this. So you can imagine that it's, well, to be fair, probably like using 200 and something here would be better because that's the number of characters, but I still think like any formula here is gonna work, right? So it's like adding some kind of, like, we want to add the characters together somehow into a number, and I guess that's the easiest way to do it. Probably it's not the best way, but it's clearly the easiest way. And for compare, easiest way to do that is with string compare, and yeah, we just want char pointer k1 and char pointer k2. We just want to string compare it. Okay, so that's kind of everything in the example. Now we should probably try and implement these functions because right now they are not implemented. So yeah, if we go to ds.h, just curious. Yeah, here I was using with allocator, but that's simple enough to change, right? But let's, wanted to see if I still use like that because I don't remember. It's been like a really long time since I added something to this. Yeah, I also have to make sure I use ds.malloc just to make my life easier. And I think that's the only like quirk in the, oh, and ds-free. Yeah, let's not forget like ds-free. Yeah, I mean, clearly here I made some mistakes. Like here it uses no allocator, but here I used an allocator. So yeah, but yeah. Anyway, let's see. So we are gonna need something like this, but probably also result. I said it's gonna return some stuff, so let's have defer return result. So yeah, let's just take that and we'll have something like map, arrow, I think it's items, right? Yeah. We want to do ds.malloc, and for now the allocator is gonna be null. Wait, how does ds.allocator alloc work? Ah, interesting. Yeah, this was a really cool video, if I remember correctly, doing the allocator in C. That was really interesting. But yeah, anyway, so we do capacity, and here we use this dynamic arrays. I believe it's weird. Probably we should use yeah, I don't remember why I use this one here. Oh yeah, actually I do, but it's gonna be ds hashmap kv, because we want to keep items of this type in our array items. So yeah, we allocate the hashmap items, I guess. Right. And I think that's the only big part of it. I see, I remember now. But we can talk about this stuff after we write our first init function, because that's gonna be interesting. Map hash is gonna be hash, and map compare is gonna be compare. So, like, an interesting question would be, okay, but what happens if we have how I called it, like a conflict between two keys? Like, how do we manage that thing? And the easiest way to do it is just have a +1 on the index, right? And I guess, you know, that's the easiest way to do it. But the next best thing is to use buckets. And what buckets would do is that instead of having a linear array here, we would have something like a 2D array. So you can think of it as, well, we have our big list of items, and let's say that instead of only one cell representing a single key, we have, like, okay, 10 cells represent um, a single key. So now if we have 10 conflicts, we have space to put inside of that part of the array 10 items with the same hash. So that would be the idea. And if we use a dynamic array instead of just strictly 10 items, we can have however many, because we can allocate more space in a dynamic array. So I think that's why I think that could be a good idea to store dynamic arrays. I think that could be pretty cool. I'm curious, did I define it? Yeah, I said this dynamic array. Well, why not, right? Let's try to also have that. Dynamic array is gonna be buckets, and this one is gonna have type ds hashmap kv. So that's what it's going to store. And it's a bit of a change in the data structure, but still useful, I would say. So then buckets, we'll do here ds dynamic array, and then we replace that with buckets. All right, and now we just have to initialize each dynamic array because they are not initialized. So yeah, let's go from int I is equal to 0, I should be less than, obviously, hashmap. Capacity is capacity. To map capacity I++, and I would probably do something like this, dynamic. So we still need dynamic array, the implementation for dynamic array. Looks weird, I think it was DA. DSD implementation, okay. Right, so we do this function, which takes a reference to a dynamic array, and that dynamic array is gonna be, map buckets plus I. It's the easiest way. And we need the size of each item, I would assume. So yeah, item size. And the item size is gonna be size of hashmap kv. So now instead of storing all the key value pairs in a single list, we just have a list of lists, if you think about it. So we have buckets, and then we have our thing here. So let me just okay, so it doesn't do anything. It cannot really fail. That's perfect. So I'd say that's how we initialize our hash map. Maybe hash table. So it's gonna be similar to this one, but yeah, here I was keeping the keys and the values separately in two different arrays, which yeah, I don't know. I think it's gonna be better like this with a single array, but we'll see. So next up is the insert, which let's see how it's gonna work. So first thing is to compute, well, first thing usually is to build a return defer, but that's to 0. Okay, but yeah, the first step would be to get the index, and that is by using hash on kv, right? Hash on kv, but here we need just the key. All right, So that's how we get the index. And yeah, that's why it sucks, like C sucks a bit, because here this one takes a void pointer. So depending on how you implement your hashing function, you have to be careful. Like here, this is going to be just the key, but you can actually have anything in here. So yeah, well, that would be the first step. And the next step is to just let's try to build it step by step. So dynamic array append, we want to append into a bucket, but we need to find which bucket we want to append to. And what do we want to append? Well, we want to append the kv, our key value. And the result could be that, but I prefer to also error check. But let's figure out which bucket it is, right? So bucket is gonna be clearly from the buckets, but we need to offset it with index. So that should be everything. Let's do the error checks, and if it's not 0, we can log an error, failed to insert item into bucket. Return default 1. Okay, guess that's all for this step, which is pretty neat. Let's do the get. And yeah, here we don't really care about conflicts, because as I said, we have buckets, and when we do insert, we just want to append more and more items to the buckets. Sure, it's gonna be a bit painful if we have, imagine, a single bucket with 1000 items, but the O of n, I think it's more like O of n on average, so like O of n amortized or something. So yeah, like it is what it is. If the hashing function is bad, the performance will be bad. So yeah, like this one clearly is not the best hashing function for strings, but we just use it for example. So yeah, that's gonna be like, that could be an interesting topic by itself, figuring out a good hashing function for strings. But for now, let's try to continue with HashMap get. So HashMap get clearly is gonna be similar. We want to find the index of the bucket, but now it's gonna be kind of interesting. We also need a hash map. Well, we'll do that afterwards. So we know in which bucket we need to look, right? Because we computed the hash. So let's do that. So let's do I is equal to 0. Right, so we know, let's just say dynamic array bucket, and let's make it a pointer. It's gonna be map buckets plus index. So we know we have to look into this bucket. Bucket dot count. Well, it's arrow count. Right, we iterate all the possible options. Map kv, and this is gonna be like option, temporary, just like that. And we need to use the dynamic array functions now. So we want to get from bucket, I guess, into temporary from index I, right? Should be the other way around. Okay. So we want to get this this item from the bucket, and if map compare between kv key and temporary key is 0, because that's how I expect compare to work. So if the keys are the same, then kv value should be temporary value, and we can also just break. Right, and maybe we can have another integer found, and we just set, I don't know why I wrote found is equal to 1. Right, and I guess if found is equal to 0, fail to find item in HashMap. Right, because this thing is always going to return an index, right? No matter if the item exists or not, then this is always going to return a bucket, because all the buckets exist, but the bucket either can be empty or neither of the items will match the key. So found is still going to be 0, and that's when we don't have an item. Right, I think that makes sense. That's when we don't have an item. So how about we just comment this thing out and probably the free, and let's try, I guess for examples, god damn, the makefile is complicated. I guess it makes examples. Oh, it just builds them. Okay. Oh no, I'm crying. Well, segmentation for that's really nice. We could do log info initialized HashMap. Well, we initialized the HashMap. That's nice. I'm gonna say probably the insert failed. Inserted John. Let's see. Yeah, looks like that. Do I make with -g? Yeah. So at least we have like we could valgrind build HashMap and see where the error happened. Like that's easiest way to do it. So at line 53 is where, well, no, I wanted to see, I guess, oh, it's the other way around. Okay, so 116 is where we do insert John. All right, and then, oh, now I deleted the stuff, so let me just redo it. So 115 is where we do insert John, and then line 53 is where the dynamic array insert happens, and then 967. Oh, so I didn't set count and capacity probably. Or what is the issue? No, but I did because I initialized all the buckets. Excuse me, what? Access not within mapped region. That's insane, what? I mean, it says that address is not malloced, but it clearly should be. Oh my god, I forgot, yeah. So the hashing function could return like a number that's outside of our range, right, of the range with 100. So define max capacity, let's say it's 100, and to make our life easier we modulo this by max capacity. And yeah, but now the question is, who should handle that? Should our HashMap library do here modulo map capacity, right? Probably we should also do that here, just in case the user doesn't do it. The name is John. Holy shit. The name is John indeed. Right, so we got that. And yeah, so the issue was basically that the hash was probably like a huge number, and when we tried to get the bucket for that hash, it was out of range. But errors in C are most of the time gonna be just segmentation faults. But yeah, I really think that if you are programming C and you are struggling, try to look into the -g flag and then use valgrind when you get segmentation faults. Like -g adds debugging symbols. So how can we replicate that? Let's just go back to not having modulo max capacity. So now if we get segmentation fault, right? Let's check the make. So if we remove -g from there, so make clean and make. If we run this function and we run it with valgrind, we don't get like any information. It's like, well, it happened in main, it happened in insert, it happened here, but we don't really know the lines, right? But if we add -g, make clean, make again, if we run this one, it's gonna tell us exactly the line where it happened. So that's something to keep in mind. Like make sure to use -g in like GCC. So oh yeah, that's where were we? I think delete. So let's just copy. Let's just copy this one. And delete takes in just the key. Const void pointer key. Okay, so here we need to do just that. Here we need to compare this, and this kind of sucks with the dynamic array because we want to delete from the dynamic array. So maybe I can do something like dynamic array delete, and then bucket and I, but we don't have this function yet. And I feel like I should add it myself because it's like not relevant to hash maps. So yeah, we should do dynamic array delete, and then again check if we found item or not and say that. Okay, but yeah, we want to do this stuff. And I guess freeing, so because this doesn't also free the key and the value, I think for free you are supposed to do a get first and free the stuff manually because you allocated the stuff. I think that's fair. Let's just add back the delete, and let's imagine we have this, but we don't have it yet. We do a make, and if we run the stuff, it actually found the key, and in quotation marks it deleted the key. And if we also want to do free, I say that free is going to be similar to init because you'll see in a second. HashMap free. Let's remove all of that, so we don't need capacity, we don't need to allocate anything. We just go to all the buckets and we free them. Again, this won't free the items themselves, it just frees the dynamic arrays. So yeah, if we want to manage the memory inside the hash map, we would need an extra free function in here. So I'd say that should be managed by the user because ds hashmap doesn't really allocate anything, right? So if you insert stuff that's allocated, you have to free it yourself. Yeah, I guess that works for me. So, and this would be part of the hash map. So what I'm gonna do is probably just gonna copy this stuff into ds.h, and I also have to implement this thing myself, and I think I'll also implement, maybe it's gonna be useful, dynamic array insert bucket I and item, but yeah, maybe not sure because yeah, like delete can make sense, but insert I don't really like it. Like it's not necessarily insert, but it's more of an update. But I mean, probably you don't care about the dynamic array. Yeah, maybe I'm gonna do update, but delete kind of makes sense, especially that we use it here. But yeah, okay. So yeah, I guess that's pretty much everything. I'm gonna add this stuff into ds.h and probably publish it once the video comes out. So you can actually just use the hash map, right? And we'll see if we, I don't know, parse some JSON or something and use the hash map, or maybe going back to the PDF parser, if we can actually change our implementation to use hash maps. But that's kind of not important because the lists are 5 items, so even by using a hash map, it's the optimization, I think you fill the optimizations after like millions of items in an array. Like, I don't think like 1000 items is different between O of n and O of 1. Like at 1000 items, it's like probably nanoseconds difference. So yeah, we need a real use case with 1 million items to check for the hash map and maybe compare it. So yeah, we can try to do like a benchmark with this hash map versus the Python one. Although I'm pretty sure even if we do a list in C, it's gonna be faster, but it's a bit unfair. But yeah, we'll see if we can do something like that, or yeah. But all in all, I'm gonna put this into ds.h so it's easier for everyone to use it, and see you in the next one.